Right, so this is June 2009, so we're going back a bit to the previous decade of past papers. Might have been a little more challenging than what we've seen so far, right? So let's get started. Items 1 and 2 refer to the following atoms represented by their electronic configuration. Match each item below with one of the options above. Each option may be used more than once or not at all. Right, so 1, combine to chlorine to form ionic bonds. We all got for that one. Which one would combine with chlorine to form ionic bonds? And the clue here would be the amount of electrons on the outer shell, right? We're looking for metal. A metal has to combine with chlorine to form an ionic bond. So which of those would be a metal? Yep, that's correct, Sharon. D, right? This is a group 2 element. Yeah, possibly potassium. Right, so D for the first one. 2 forms many giant structures occurring both naturally and artificially. Which one is that? So I'll give you a little hint. Carbon forms graphite and diamond. Yep, very good, Sharon. Carbon is actually has the atomic number 6, which will give us the electronic configuration 2,4. Yeah, so E. Very good. So number 3. Number 3 says, in which of the following are radioactive isotopes not used? Where we don't use radioactive isotopes. So there's radiotherapy. There's the radio in here, so I mean that's kind of obvious. Carbon dating, we know that. Very good, Jadon. C, metal extraction. We've not seen the use of isotopes inside of there, right? Because we know metals are either extracted using electrolysis or a reduction method. 4. Which of these elements has 7 electrons in the outer shell? Group 7 elements. Group 7, no group 7, the halogens. Oxygen, no, oxygen is actually a group 6 element. So oxygen is 8 on the outer shell. Try again. So which one? Oxygen. The oxygen is 8, so 6 on the outer shell. Correct, Jadon. Chlorine. Chlorine is in group 7. Chlorine has that atomic number 17. Right, this has the atomic number 17. Right, so 2, 8, and 7, group 7. Okay, so what you want to practice doing, guys, is just to know, apart from the table, the sorts and stuff, you want to be able to list out all the elements like this. Lithium, beryllium, boron, carbon, and then number them like this. You do the first 20 just like this, right? And then you do the electronic configuration. Next step. Right? Important I have this, especially if you plan on doing chemistry going forward. You must know those first 20. Yeah? Great, so moving back up, 5. The ionic equation for the reaction between an acid and a carbonate may be represented by which of the following equations? Right, so we know acids react with carbonates and they produce a salt, carbon dioxide, and water. Well, which of these is the best ionic equation for that? Yep, that's correct. C. Right, because we need two of these here. Very good. Well done, Jalen. Now for a tricky one, 6. Which pair of atoms form covalent bonds when reacted together? Right, so missing on the side is probably another 2 electrons here. Right, because you can look at the number of protons here. Number of protons here I think is 16. Right, so that'll tell us 2, 8, 6, or group 6 elements. possibly sulfur, if that is the case. That means it's in the same group as oxygen. Oxygen is just above it. Right, so which of these would form a covalent bond? Bear in mind that this here is helium, because it has 2 electrons on the outer shell. That's why it's important. Remember when I did this H-E-L-I-B-E. 1, 2, 3, 4. 1, 2, 2, 1, 2, 2. Right, so look at this. This is this fella here. See? So that's a noble gas. So anything with Q in it is actually wrong. Because they're not going to bond with anything. A noble gas to bond is chemically inert. Right? Group 8, or sometimes they call it group 0 for your noble gases. Right? So this has the electronic configuration of helium. This has the electronic configuration of hydrogen. 8 protons as oxygen. Right? And this one has 16 protons. See, 8 there tells me 2 and 6. 1, 2, 3, 4. Oh no, wait, I have this wrong. Am I checking something incorrectly? I'm kind of blind. Well, this is not a we have 8 protons here. We're seeing 7 electrons on the outer shell. Sorry, 5 electrons on the outer shell. So that's kind of like a nitrogen structure, right? But generally, the point I was making here is Q is helium as a noble gas. So anything with Q doesn't make sense. This would be my correct answer here. P and S. Right, and if you look at it, no problem, Navin. That's alright. You just at number 5 now. Just not too long started. Right, so P and S. P and S would give us a covalent bond. Right, hydrogen here is this S has 6 on the outer shell. 1, 2, 3, 4, 5, 6 that I'm not seeing. So you actually have 2 more hydrogens there. Yeah, so that's actually H2S that will form hydrogen sulfide. Right, so 6, correct answer is B. Right, P and S would give us a covalent bond. Everybody right with that? Give me a 1 in the group if you're okay with that one. In the group chat. Alright, excellent. 7. Which of the following is the type of crystal structure of iodine at room temperature? What about for this one? Iodine at room temperature. Simple molecular. Yeah. Iodine is a non-metal, so it's not going to be ionic or metallic, and it doesn't give any kind of properties of giant molecular. Yeah, make sense? What are some examples of giant molecular? Giant molecular, yeah. Diamond, yeah. Graphite. Very good. 8. A metallic bond is formed when which of the following happens? Cations are held together by a sea of mobile electrons. Positive metals are held together by a sea of anions. Anions are held together by negative electrons. Metals are held together by molecular forces. Yep, you're correct. E. Right, metallic bond is cations, and they're held together by a sea of mobile electrons. Very good. 9 refers to the following graph, which shows the boiling point of some straight chain alcohols. Here they're asking us the most suitable method to separate a 4-carbon alcohol from a mixture with a 5-carbon alcohol. Right? If you look at it here, their boiling points are relatively close. There's this one here and there's this one here. What method do we use when the boiling point is very close? What options you have? Simple evaporation, simple distillation, solvent extraction, and fractional distillation. I think solvent extraction we could just cross that off one time. That doesn't make sense. And simple evaporation, I mean, what's that? So what do you all think? Yeah, fractional distillation, right? You use fractional distillation when the boiling point is relatively close, yeah? Most of the time involving alcohols, yeah? 10. Which of the following is the correct formula for ammonium carbonate? Ammonium carbonate. What's my charge on ammonia? Nobody remembers? That's that table I sent some time ago. Ammonia is NH4 plus. That will tell you here. And carbonate is CO3 2 minus. So if you go with the cross method, you all know the cross method, what are we gonna get? Just carry the number instead of the sign. Yep. And get NH4. And we have to put this in our bracket. 2, because we're taking this 2 from here. We need 2 of these in order to cancel, to neutralize the negative 2 that we have here. And we just have 1 of this. So C. Yeah, makes sense? So about that? Everybody alright to that one? 11. Which of the following separation techniques is not used during the extraction of sucrose from sugarcane? This is an easy one. There's one that stands out there that's totally unrelated to anything done in the extraction of sucrose from sugarcane. Think it's sugar production. They still do that in primary school and things, which is totally off. The filtration is where we have soluble and insoluble, right? Precipitation is where you have you try to form an insoluble salt to get rid of one of them. Centrifugation is a technique where you use to separate particles of varying size, and you spin them around in a particular way and they would separate based on the densities. Chromatography we use when we're looking at extracting dye, seeing like what an ink is made up of, and we use the wet paper, yep, and we dab the paper and then you'd see all the colors separate out. You remember the experiment from school? Yeah. So D is the odd one out. D is the one that is not used during the extraction of sucrose from sugarcane. So D is correct. And D is our answer. 12. Which of the following does not affect the solubility of a substance? Solubility of a substance. Remember this one. Stirring. I don't think you could use a catalyst to increase the solubility of a substance. A catalyst is you use the catalyst to speed up a reaction, but I mean you could stir to dissolve something. I mean sugar is not readily dissolved inside of water when you're making juice. We would stir it, and that would help to dissolve it faster. Pressure and temperature, well, those two usually affect solubility and heating and freezing and things like that. But catalyst is specifically used to alter the rate of a reaction. It provides alternative pathway, right? So that doesn't have to do anything with solubility. So 12 is A, catalyst. Right? Everybody okay with that one? 13, a piece of calcium is added to some distilled water in a container and a gas is produced. The gas produced is expected to, so we added calcium to water, more than likely that gas would have been carbon dioxide. So what does carbon dioxide do? Relight a glowing spin, give a pop with a lighted spin, decolorize acidified aqueous potassium manganate turn acidified aqueous potassium dichromate green. So now I'm wondering if it's carbon dioxide. Let's go back to that question. Oh, guys, I sent this in the chat last night actually. A piece of calcium. Calcium is a what metal? Group 1, group 2, group 2 metal. Group 2 metals, when they react with water, they form the hydroxide and hydrogen gas. Right? Check back our the note that I said on trends in group 1 and group 2. So that gas that is evolved is hydrogen gas. So which one of these things would that gas do? We light a glowing splint, that's oxygen. Give a pop with a lighted splint, hydrogen does that. Yep. And decolorize acidified potassium manganate, acidic gas would do that. Turn acidified potassium dichromate crystals green, and the acid would do that. Alcohol would do that as well. Yeah. So correct answer for this one is B, right? Gives a pop with a lighted splint. Everybody alright with that one? 14. Which set of elements has atoms with 2 electrons in their outer shells? Two electrons in the outer shells. How will you know? The halogens. Halogens is a group 7 element. They should have 7 in the outer shell. Period 2 elements. Well, in the outer shell it will vary because they're in period 2. We know that they will have 2 shells, but we can't group or summarize all the elements in period 2 as having one specific number of electrons in their shells because the period runs across, right? So each time we move one block across, the number of electrons in the outer shell will increase, right? And transition elements, well, they vary. They are actually +3, +4, +5, or not +5, right? Mainly the +3. So group 2 elements, our calcium, we just saw calcium a little while ago, 2+, they lose 2 electrons. Yeah? So correct answer for this one is C. Yep, group 2. Ready, right to that? 15 to 16 refers to the following types of substances: a salt, a base, a alkali, a acid. Match each of the following below. You could use something once, more than once, or not at all. 15, the oxide of a metal. What is the oxide of a metal? Let's just take some metals. Again, I was in the note I said last night. So, magnesium oxide, right? Again, what's the oxide of a metal called? Magnesium oxide is a salt, a base, a alkali, or acid. Which of the four? Magnesium oxide. Yep, magnesium oxide is a base, right? So a metal oxide is called a base. B for base. Yeah, example here. 16, supplies protons as the only positive ions in aqueous solution. Who does that? Who's a proton donor? Yep, very good. D, acids. Right, D, proton donor. 17, when X and Y are stirred together in a beaker, the mixture filtered. X and Y are both present in the filtrate. Which of the following could describe the mixture formed by X and Y? Let's go there. You mix it together, just run it through a filter paper, but then everything end up inside of the beaker. A solution, a colloid, or suspension. Well, we know what a solution is. That's the water and sugar. That's a solution, right? You have a solute and a solvent. One is being dissolved by the solute is being dissolved by solvent. What about a colloid? Was a colloid? Anybody remember the definition for colloid? add one definitions. Have one. Let me read it through it actually. See what definition I'd like. Here it is. So basically it's a homogeneous non-crystalline substance. Homogeneous means it's the same throughout, right? Consisting of large molecules or ultra microscopic particles of one substance dispersed throughout a second substance. So examples of colloids would be like gels, salts, emulsion. So mayonnaise is an example of that, right? And what about suspensions? What are suspensions? What's an example of suspensions? You don't know that one. It's like a sand and water, right? Chalk and water, muddy water, flour and water. All of those are suspensions. But we know when we filter a suspension, you'll get a filtrate, correct? That makes sense, right? If I filter flour and water, the flour would remain in the filter paper and the water will be collecting beaker at the bottom. That'll be more filtrate. So anything with three doesn't make sense because suspensions can't mix, right? For us to find it in the present in the filtrate, right? So this is out. So this is out. This is out. So your toss up now is between this and this. But based on what I told you on what a colloid is, this description here could either be a solution or a colloid. A colloid is a homogeneous mixture. It is not separated. It's like gel, right? So my correct answer for this one would be C, 1 and 2 with me. Everybody all right to that one? Drop a 1 if you understand. Right. So the examples of colloid would be like whipped cream, mayonnaise, milk. Milk is an example of that. Milk is a perfect one for us to use here, right? So we mix milk and water together and you filter it. Until you get milk and water in the filtrate, you would. All right, so moving forward. 18. Which of the following compounds are acid salts? Acid salts has the presence of a hydrogen atom in there. All the hydrogen wasn't fully liberated. So which two you see in acid salts? Presence of hydrogen inside of the salt. Yep, that's correct now in 1 and 4. Right, 1 and 4 B. That'll be an acid salt. Yeah. 19 to 20 refers to the following chemicals. Right, and I'm going to read this. Which of these chemicals react with an acid liberating a gas which turns lime water milky? Something that's going to give us carbon dioxide. So what reacts with an acid? Acid reacts with carbonates to do that, to provide, to produce carbon dioxide gas. We saw this earlier, water and the salt, yeah? So you're right, E, calcium carbonate is going to do that. 20 reacts with sulfuric acid to produce hydrogen gas. Metals react with acids to produce a salt and hydrogen gas. Right, so 20 B. Right, B for magnesium. 21. Elements are arranged in a periodic table on the basis of their atomic mass, mass number, atomic number, neutron number. Mix everything up here to see if you really know your stuff. Always arrange a periodic table by as you go across the period, what increases? The give you a hint, it starts with E. Right? And there's nothing like atomic mass. There's no atomic mass. There's no neutron number. There's a nuclear number. Right? So between which of these two? It's mass number, atomic number. Sorry. Right? So the elements are arranged based on the atomic number. And that's the same thing I was just telling you. H, E, Li. This is the atomic number here. BE4. Right? And the atomic number tells us the number of electrons. So that's why we could do electronic configuration here. Number of electrons in a stable atom. 22. Which of the following is not a use of the periodic table? Take your time with this one. Not a use. It's summarizing the properties of the elements. Summarizing, you see. Right? That's like if I give a lecture and I tell you, summarize the points I made. I don't think the periodic table is a summary. Right? Fixing relative atomic masses. It does. Right? It does. Predicting the existence and properties of undiscovered elements. It does that as well, because once we could determine which group it would belong to, right? We would know, what type of properties they would have, right? And if other elements in that particular group can exist. So this is possible. And for determining the densities and melting points of elements, yes, we could do that from the periodic table. When we look at that same thing that I sent you, trends in the groups, or trends across a period. So our answer here is A. Right? The periodic, this is not a use for the periodic table. Summarizing properties of the element. You can look at the periodic table and you could classify elements. Yeah, classify would have been a better word, but summarize, nah, wrong choice of words there. Right, so that was a bit more English than chemistry. 23. The alkali metals. Another one in the notes I sent last night. This is group what? 1 or 2 or 3 or 4 or 5 or 6. Yep, that's right. And what is the group 2 metals called? They are the alkali what? Earth metals. You know why they call them the alkali earth metals? Right? You usually find them in the earth in a combined state because they're too reactive to be uncombined. Right? So the earth metals, so you usually find them as like sulfates or carbonates. Right? You wouldn't find magnesium sitting around somewhere waiting on you to extract it. Silicon and carbon are in the same group in the periodic table. Right? Carbon has an atomic number of 6, guys. Right? So that means it has an electronic configuration 2,4. Silicon, same group. That means a group 4 element. The formula for silicon chloride. Right? If you remember your tetrachloromethane, CCl4 from the halogenation of your alkene. Yep, this would be the correct formula, right? Because we know that carbon combines with chlorine to give CCl4, and I just showed you that you need 4 more electrons to complete the outer shell as well, yeah? And chlorine could give 1 electron. So we need 4 chlorines to 1 silicon or 1 carbon. Right? Both will work the same way. 25. Which of the following pairs of elements are in the same period in the periodic table? Same period. So even if you don't know elements going across the period, you would know elements are in the same group. So sodium and potassium, they're both group 1 metals, so that's out. Fluorine and chlorine, they're both halogens, so that's out. phosphorus and oxygen, I think they're both group 4 as well. Or no, they're in separate groups. But they're not in the same period, so that's out. Aluminum and silicon, they're actually next to each other. Aluminum is 13 and silicon is 14. Right? Another reason why we need to have those first 20 elements. I want to make sure I had them first 20 elements down. Right? So 25 is B. Right? Aluminum and silicon. Check it out when you get a chance. 26. In which of the following groups of the periodic table would you expect to find an element X with the greatest basic characteristic? Out of the options given here, basic characteristic. Any ideas? Yep, that's correct, Navin. E is for 26, right? Yeah, same thing in the trends I was just showing you. Your group 2, they form the two metals form very strong bases, very the oxides, very basic. Yeah? See that on the handout that's in 27. In the arrangement of elements in a periodic table, which of these here makes sense? I'm gonna let you all pick your brain a little bit for this one, and then I'll put in my 2 cents. Right? Metallic character of elements increases from left to right. So if this is the periodic table here, it's saying if it's increasing from left going to right, that this here is where your metals are. There's most metallic items. In reality, this is actually where noble gases are. Alright. Marvin has I think he's on to it. Non-metallic character of the element decreases from right to left. Non-metallic. That would make sense because on this side is the most metallic elements. Group 1, group 2 is down on the side. See, the most reactive elements are found in the center of the periodic table. Well, that's not true because your group 1 elements are actually the most reactive. The elements are arranged in order of decreasing densities. Well, you know that's not true because we saw before that's arranged in here, atomic number. Right? So B is our correct answer. Yeah? B. 28. Beryllium has 2 electrons in its outermost electron shell and a total of 2 shells. The number of electrons present in an atom of this element is, what we'll get here. So this is beryllium. The same beryllium have as a nucleus. Beryllium has 2 shells, 1, 2. Right? And again, if you know your H, E, L, I, B, E, well, by now you already know these first 4 by heart the amount of times I draw it already for the evening. Look, 1, 2, 3, 4. See it? And even if we had to work it out, I mean 2 shells, right? 1 shell, 2 shell, and 2 electrons in its outermost shell. So that's 1, 2, and we know that this first shell, for it to be completely filled, it must have 2 electrons there. Right? So correct answer for this is 4. Yeah? 29. Which of the following statements is false in a given group as the number of electron shells increases? I think we were talking about this last week. The shielding of the nuclear charge. Which one is false, they say? Atoms increase in size. The electrons in the outermost shell are less strongly attached to the nucleus. That's correct. Reactivities of the elements decrease. That's suspect. Reactivities of the elements decrease or increase depending on the actual group. Yep. As the number of electron shells increases. Yeah, this is false. It doesn't decrease. It'll be further away from the nucleus. So it actually should increase. Yeah. 30. The maximum of electrons which a particular electron shell can accommodate is given by the formula 2n to the power of 2. Right? Where n is an integer, so it's a whole number, representing the number of the shell. Right? What is the maximum number of shells in an outer shell of an element in period 3? Period 3 would tell me that there are 3 shells. Right? And n is a number for an integer representing the number of the shell. So 2 by 3 to the power of 2, that's 2 by 9. Right? But we can't stop there, that's 18. We need to actually draw the electronic or write out the electronic configuration. 2 and 8 is 10. And 8, 18. So the correct answer there. 9, 9 2s are 18. That's argon. Yep, B. B is the correct answer. There's 8 electrons on the outer shell. Right, so this is, we look at the periodic table, argon has the atomic number 18. Yeah. More than 8 on the outer shell. Yeah. Wait until you reach form 6 and then you will see how everything is changed in chemistry. Yep, it could have more than 8. I think, yeah, 16. I'll leave that alone. I'm not going to spoil the surprise. I had to go through it, so yeah. Chemistry in Form 6 is like, you know, after you come out of primary school and then you go into secondary school and then all of us suddenly realize -3 could add to 7 and stuff like that. Yeah, that's what chemistry going to do to you by the time you get out of this. This is like the simple stuff. 31. Elements in group 0 or group 8 or in noble gases, they do what? Possess no electrons in the outermost shell, identical in structure, chemically inert, are unreactive solids. Which of these make sense? Group 0. Group 0 is your noble gases. Yep, that's correct. They're chemically inert. That means that they do react. They can't give or take electrons. They have a complete outer shell, so you know they're always chilling. They're not trying to gain or lose anything. 32. The halogens are placed in group 7 of the periodic table because they what? Have 7 valence electrons, ionized by gaining electrons, possess identical properties, are all oxidizing agents. Yep, have 7 valence electrons. Right, so moving up. 33. Which of the following statements about transition elements is false? There's one obvious answer here. Yep. mean, how you would say something like that, right? Iron is a transition element. Iron is not unreactive, right? So this is my correct answer here. 34 of the elements sodium, potassium, chlorine, and iodine. The most metallic would be the one that gives up an electron the easiest. That's when you say something is metallic, that's basically what you're saying. Most metallic. Yeah, that's right, potassium. It wouldn't be sodium because remember I was telling you about with the smaller one. Sodium has electron closer to the nucleus, so the nucleus will be pulling up. Potassium is actually below sodium, so it'll be more metallic than sodium. It'll be more reactive. It'll be easier for it to lose an electron. Right, so my correct answer here is B, potassium. 35. In which of the following compounds is dative bonding present? Dative means double bonding. Right? Methane, you remember methane? Methane involves the sharing of bonds, but it's just single monovalent. Right? Hydrogen given one, carbon given the other, and that's actually how we get methane. Alright with that? Carbon monoxide though, I mean if we have carbon here, right? Carbon has 1, 2, 3, 4. Right? Oxygen has 6 electrons on the outer shell. 1, 2, 3, 4, 5, 6. So what's going to happen here is you're actually going to have double bonding taking place. When we do this, right? Should I make this a little bigger? Sorry. Yeah, B is the answer. That's correct. I'm just going to show you how. Right, so this is carbon, this is oxygen. 1, 2, 3, 4. Right, so this is the remainder of carbon electrons at the X's. And 1, 2, 3, 4, 5, 6. Right, so double bond or dative bonding happening here. B. Right, we don't need to go further. Yeah. So B for this one. Carbon monoxide shows dative bonding present. 36. Which of the following statements is false? There's one there that you would know because we always talk about adding something to something else to make it more conductive or being able to conduct more electricity. Right? A hint is ionic type compounds, they conduct electricity. My question to you is, water a good conductor of electricity? Yeah, that's right. B. This is false. Water is not really ionic. Water is said to be not bipolar. That's how you used to describe people. Water is a polar compound, right? They form these. It's not by itself, but when you have salt dissolved here, that's what I was talking about. You see that in the other papers. Water is what you call a polar compound. What happens to the water and the oxygen and the hydrogen is they create these small charges, delta positive and delta negative charges, and that's what attract more water molecules to each other, but they're not ionic. There's a slight charge on the hydrogen and the oxygen, kind of technical kind of thing, but there's a slight positive and negative charge, but they're not ionic. Right? It's not strong enough to say that there's a positive or negative charge. So they refer to water as being a polar compound as opposed to being ionic. Right? Probably Google it when you have some time. 37. Which of the following statements is false? Metals are good electrical and thermal conductors because atoms are very tightly packed. That's true. They have that lattice-like structure. Outer shell electrons of the atoms wander away from the nuclei and form an electron cloud. That's true too. I mean, there's a sea of moving electrons that is talked about, right? Electron cloud can constitute an electric flow or current. That's true. That's why it's conduct electricity. The cations form when electrons are lost, vibrate. That kind of suspect. This one, false. Yeah, D. Good. 38. Solid sodium chloride, although composed of ions, is a poor electrical conductor because what? Solid sodium chloride. This is our salt, table salt. Why is it a poor? D? No. Ions have neutralized each other's charges. Dumb. Makes no sense. Ions are bonded and hence are unable to move. Yes. Ions are moving too rapidly. No. Solid vaporizing where electrical energy is supplied. No, it's not in movies. Right. B. The ions are bonding, so they're unable to move. Remember, the sodium chloride, they bonded together in a crystal form is a solid. It's a crystal structure. That's why I say table salt. Right? So if I take salt and I try to electrocute salt, there's nothing going to happen, right? If I dissolve it in water, electricity will pass through, right? 39. Type of lattice structure exists in liquid ice. I guess they say liquid ice here so that I don't confuse it with dry ice, frozen carbon monoxide. So ice, ionic. Does that make sense? Ionic has to have a metal and a non-metal. What's the atomic structure? I don't even think that's a thing. Metallic structure. Well, ice is not metallic. And that'd be weird if you've been eating ice, metallic ice all the time, right? Simple molecular, yeah. Ice is a simple molecular structure or type of bonding. Other examples of that would be like iodine like that. Dry ice, the same solid carbon dioxide is actually simple molecular as well, right? Sulfur and iodine are the examples of that. Right, so they compose of this molecular lattice. Small molecules, so you get that same crystal-like structure, but they have weak intermolecular forces. So you can throw ice in the ground, will shatter. Yeah. 40. From the information given below, the table given below in the table below, all right, which of the substances A, B, C, or D is most likely sodium chloride? Sodium chloride, ionic bonding, so we were looking for something as high melting point and conducts electricity in an aqueous state, but not in a solid state. Right, so solid state, this is out. Why is it conducting electricity in a solid state? That's not supposed to happen, right? Boiling point, this is too low. And then we left with these two, too low. Aqueous state conducting, yes. This one says no, so this is out. So my answer is E. Very good. 41. The smallest particle of a chemical compound that can take part in a reaction is the smallest particle of a chemical compound. This is weirdly worded. What's your thoughts on this one, guys? Jaden says D, molecule. Yeah, kind of leaning towards that too, yes. Anybody else? Yeah, nothing else that makes sense. I agree with you, Jaden. Because you say part of a compound, it had to be a molecule. It can't be an atom, because there are different atoms in a compound, so then you'll be leaving out stuff. A mole, I mean, that's not particle. A mole is like a unit of measure. Formula doesn't make sense. So molecule is your best answer there. I really like that question. Good job, Jaden. Well done, Navin. 42. A solution has a pH of 1. This solution would be expected to do what? Solution of pH 1 means as acidic. Yes, react with zinc metal to produce hydrogen. Very good, Navin. 43. Which of the following statements about ionic compounds is true? They contain molecules. How does it make sense? They are solids and vaporize easily. Neither. Usually dissolve in organic solvents. Not. They conduct electricity when melted or dissolved in water. Yep, that's correct. Very good, Navin. This is the correct answer here. 44 refers to the following graph, which shows changes in temperature with time for a substance heated until no further physical change takes place. During which portion of the curve is the substance a liquid only? Where are we a liquid only, guys? Liquid only. Do you have any ideas? I think I'll download a picture just to show you, let's see if it's still there. I'm not sure. I'll share. So look at this one here. So this is a heating curve, right? So as the temperature increases, you're looking at water. It's saying water being heated as a solid. I guess that's ice, right? Because this is minus 30 underneath here. Then it melts, right? And then we have water being heated as a liquid now. Then it vaporizes and then changes to a gas. Oh, now see. Yeah, 3. Why is E option? Yeah. I don't know what happened there. But this is the correct answer here. 3. Yeah. 45. Ions are not changed in a reaction. Ions which are not changed in a reaction are called what? When you do the ionic equations, those that are not involved are called? Yes, that's correct. Spectator ions, they're on the sideline standing by, they're not involved, no changes happening with them. 46. Which of the following will not conduct electricity? Not. Solid calcium, that's a metal, so that will conduct electricity. Solid calcium chloride, that's a salt, just like sodium chloride. Molten calcium chloride, it will do it because you'd free it up in a solution, that will conduct it as well. So my answer is B. This will not conduct electricity. Very good. 47. Which of the following salts are soluble in water? Remember that table? That final neater one. Well, all nitrates are soluble. You know that for a fact. What about the others? Some of them had of heat and water. All kind of mumbo jumbo. So I think the best answer for this would be A for only lead nitrate, yeah. So a smaller table there, so you know that would be good for your salts. Just send it to the group. Where are we? 48. The ionic equation between zinc and sulfuric acid. Right, zinc and sulfuric acid, best represented by which of the following? Well, an acid and a metal is supposed to give us the salt, right, and hydrogen gas. Yeah, B is correct. Zinc sulfate would be the salt, and there's our hydrogen gas, salt and gas. A mixture of copper 2 oxide. Copper 2 oxide is insoluble, by the way. Right, is our metal oxide. And copper 2 sulfate is soluble. Could best be separated by should I say insoluble and a soluble salt? Yeah, it is. One soluble, one insoluble. What's the best way? Yeah, A. Shake it with excess water and then filter it off. The copper 2 oxide will remain in your filter paper, and your filtrate will be the copper 2 sulfate. Right? So A. 50. Which of the following halogens is a liquid at room temperature? You've seen this one before. I told you it was yellow-brown in color. Remember? Anybody remembers? Yep, bromine. That's correct. 51. Which one of the following does not mix with water? Alcohol mix with water. So it's sulfuric acid. That's how we dilute the sulfuric acid. I've seen my wife add water to her milk when she's doing cakes. That mixes. You know for certain that oil floats on top of water. Yeah? B. 52. The name given to the solid left on the filter paper after filtration. What do we call that? I'll give you a hint. It starts with R. Yep, C. Residue. Very good. 53. The components of crude oil can best be separated by. How do they separate crude oil? What do they do? Yep, that's right. Fractional distillation. 54. Which of the following processes or process can be used to separate sand and water? How do we separate sand and water? That's a suspension pretty much, yeah? B, filtration, yep. Because they wouldn't dissolve, you just filter out the water and you get the sand on top. I mean, essentially that's how your filter a pond would work or something like that. 55. What technique can be used to separate a solution of iodine and sodium chloride? I'll help you a little bit to this. The sodium chloride here, it shouldn't dissolve in the solution of sodium of iodine. So it's actually going to be kind of settled. But we don't do the filtration. It's actually decanting. And I did put it up so you guys could see it. It's kind of like using a separating funnel. I don't know if you ever came across the separation technique. Right, basically removing a liquid layer that's free of a precipitate or solids deposited from a solution. The purpose may be to obtain the decant, which is the liquid free from particulates, or to recover the precipitate. Right, basically it's relying on gravity to pull the precipitate out of the solution. So there's some loss of the product. Right, let me see if there's a. They use it for wine. Wine basically does that. So the dregs remain at the bottom pretty much. Right, so gravity basically pulls the solid to the bottom of the container, sedimentation. Right, clear water may be obtained from muddy by simply allowing time for the solids to separate from the water. Right, separation may be enhanced by centrifugation, where you kind of use vibration to get to drop to the bottom. Right, and they could do this with lighter liquids, where you have two immiscible liquids or mixable. Yeah, everybody all right with that? Yeah, almost there, guys. 56. The most suitable process to use in order to separate the pigments in the chlorophyll of a plant. We'll talk about that at the starter class. Which one you use the paper and you blot it, and then you'd see it's the pigments, the ink separate chromatography. Yeah. 57. The best method used to separate a mixture of solid ammonium chloride and solid sodium chloride is ammonium chloride. You remember that? The gas? When you heat it, one is going to change from solid straight to a gas. That's because of the weak bonding. Yep. Sublimation. Which one is going to do that? The ammonium chloride. There's a very the intermolecular forces, they are very weak. 58. Two liquids are insoluble in each other are said to be immiscible. Immiscible. When they are shaken together, the resultant mixture is a, what do you call that? Oil and water. They're insoluble. You mix it together. What do you call oil and water when they shake it up together? Yep, an emulsion. Right? And the last one is a kind of, oh no, this is not the last one, is it? Two immiscible liquids may be separated from each other using a what? So oil and water. What do we use to separate oil and water? Yep, a separating funnel. Good. This is the last one. A supersaturated solution. You know what's a supersaturated solution? So let's look at Looking at a couple of things. There's a saturated solution first to begin with. Right, so saturated solution, basically to define a solution in which no more solute can be dissolved in a solvent. Right, so it's like you keep adding and adding and adding and adding, and after particular time, I mean, all the solvent has been used up. I mean, it's dissolved all of the solute already. So the saturated solution is where you have no more solute could be dissolved, right? Supersaturated, a bit different. What was the one I looked at? I think is this. I think that we know the answer already. Yeah, this was it. I think. Right. So each solution could only hold so much of a solute, right? Makes sense. If a solution has a maximum amount of solute that can be dissolved, it is said to be saturated. Adding more solute would cause it to simply fall out of solution. Have you ever tried to add extra sugar to a cold lemonade? It probably just fell to the bottom of the container and did not dissolve, right? This is because your lemonade was already saturated, right? But surely there's a way to get extra in there, right? So chemists know to make a supersaturated solution, a solution that holds more solute than it normally could in its saturated form, right? Supersaturated solutions are very unstable, meaning that the solute would readily fall out of solution if disturbed. As it does this, crystals can form, releasing heat in the process. So usually to get more in, they would use heat, right? You heat it up because heat increases the solubility um, of a solution. So which of the following conditions is not conducive to form such a solution, a supersaturated solution, right? So slow cooling of the solution, possible shaking or disturbing the solution, dust-free conditions, absence of crystals of the solute. So based on what's already there, which one you think is? I mean, as your did I have there as the for this question? No, that's not for this question. Okay, I thought it was the answer. But basically, based on what I tell you, right, the supersaturated solution is you're trying to pack more sugar inside of it. You want to say the absence of crystals from of the solute. Yeah, because I'll tell you why. Yeah, unstable condition here, based on what I was telling you, right? Which of the following conditions is not conducive meaning appropriate or like what's the conducive conditions for yeast cells to respire? Yeah. Well, I kind of have a toss up between B and D. Shaking or disturbing the solution right? And absence of crystals of the solute is D, absence of crystals of the solute, because shaking or disturbing it wouldn't cause it to come out of its supersaturated form. Usually it will be a change in temperature. Yeah. And there's a video I was looking at on our same site. I'll send it in a group chat for you guys to take a look at it in terms of how they form it. So you all thought this paper was. This is from back in the day. This is 2009. A little more challenging than before. We didn't have much repeats, right? Probably like one or two. What do you all think? Yeah? You just stop the recording.